Hello and welcome to the Spatial Solutions for Engineers webinar. So first of all, I thought I'd give you a little bit of a introduction to Bennett & Bennett. We've been established for over 50 years. We're based in Southeast Queensland in Australia, and we work on all types of surveying projects, as well as town planning and spatial mapping. So a little bit about myself. I guess you could say I'm a bit of an unconventional surveyor. I'm a bit of a nerd and I love progressive spatial solutions. My background is surveying on large civil projects, and I've worked in high-rise construction, land development, and then specialized in 3D mapping and VIM. So the purpose of this webinar is to provide engineers insight to the latest solutions available to capitalize on. We've tried to make it relevant to all engineering disciplines, and we'll aim for the presentation to be around 20 to 25 minutes to allow for some question time if we can. You can type questions anytime. I'll address them as I go if I can, otherwise we'll get to them at the end. And a bit of an overview, we'll touch on reality capture technology, laser scanning for detail surveys, subsurface utility mapping, the latest in scan to BIM, which aerial survey might be right for your project, and spatial data analysis. So reality capture, it's the trendy term at the moment. Essentially, it's LIDAR and/or photogrammetry, remote sensing technologies. Often, I guess, people see reality capture as maybe photogrammetry textured mesh models, but then a lot of people refer to reality capture as terrestrial laser scanning as well. So it does cover both. So LIDAR, or laser scanning. So essentially, they're the same things. They're just different terminology, but they're well and truly referring to the same thing. So LIDAR sensors essentially shoot a beam of invisible light to map everything within its line of sight and range in 3D. So it works regardless of ambient light conditions, so it can be done at night, and it is, I guess, a physical measurement, I suppose, rather than photogrammetry, which we'll jump onto now. So photogrammetry is the science of obtaining spatial information from photographs. So it works excellent in urban environments and mapping bare earth, like quarries and sort of mine sites and things like that. And visually they look stunning. So a lot of people are using them for visualization and city mapping. But it is highly dependent on ambient light. So whether it's dark or you've got shadows, or you're not able to see things clearly in the images, then that really is going to affect the quality of the spatial data. And it cannot map through vegetation. So that's one thing that we'll go over next in the aerial surveys section. So laser scanning for detail surveys. There's lots of advantages on laser scanning for detail surveys. Essentially reduces time on site, requires less, which obviously requires less travel, but also means you can survey areas that you don't need to physically access, like roads, which can minimize traffic control. And capturing them in 3D allows for a lot of subsequent other survey deliverables, whether it is, because essentially it's a timestamp of the site. So you use it for dilapidation or other sort of subsequent modeling. So the first case study is the Gold Coast Light Rail Stage 3. essentially it's a 6.7 K extension to the light rail system from Broadbench to Burleigh Heads. TMR wanted to be well informed early in the project, so invested in a comprehensive detail survey and also service location. So Ben & Bennett terrestrial laser scanned about 8 kilometres of the corridor, and we feature extracted all of the ground features, street furniture and overhead wires, and delivered to TMR specification in 12D. We also went above the specification in anticipation for future works. So the detailed survey was 3D modeled in 12D to facilitate it being a BIM project. That included the street furniture, your street lights, light poles, and things like that, as well as full 3D underground services. But we'll touch on that in the next case study. So subsurface utility mapping. Look, we're not going to talk about, I guess, methods of acquisition or SUI standards, but more what is available from a surveyor now. So the case study we're going to look at is Brisbane Metro. It's a 21 kilometre service connecting 18 stations and interchanges. And essentially this project will complement Crossrail Rail. It's not Crossrail Rail, it is a separate project. And BCC, Brisbane City Council, invested significantly in service location to avoid, I guess, I'm not sure if many people have heard about the Sydney light rail disaster. Definitely didn't want it to be another one of those. So Ben & Bennett partnered with 1300 Locate to deliver the project. And this one was really as comprehensive as subsurface utility models get. So the field measurement and documentation involved ground penetrating radar, potholing, manhole and pit laser scanning. And the critical part of this process is actually recording the appropriate attribute information in the field, not just the location, but when our surveyors are in the field, they need to pick up the class, the accuracy, the type, the condition and photos. And essentially that all gets fed through downstream. So essentially that's absolutely critical to do it right in the field. So when you are producing the deliverables, you've got, you're not making any assumptions, you've got the right information. So once we've captured this information, we then modeled it in 12D with all the attributes and metadata. So we created 12D tri-meshes, and that even included things like the strip trench locations. I think you can even see them in that image there, which so you know exactly where we've got full confidence in physically exposing the services and measuring them there, and the rest of them are connected through either GPR or cable tracing. And then once we've got this information in the 12D database, from there we can then prepare IFC, Revit, and Navisworks deliverables, and also can create all sorts of GIS deliverables as well. And so this enabled informed decision making at the start, but also provides downstream benefits in regards to clash detection and other modelling of design services in relation to them. So scan to BIM. Look, scan to BIM is not entirely new now. It's becoming relatively mainstream. However, I will talk about the latest developments So in the case study here is the Caboolture Hospital redevelopment. It's a $400 million refurbishment and expansion. Essentially, Bennett Bennett's been on site since about 2016. And Metro North wanted to ensure the design consultants were well informed at the start, and to create a well-considered design and minimise the impact of the hospital operation during construction. So we laser scanned over 13,000 square meters internally, including full ceiling cavities, and essentially ceiling cavity mapping to this scale and magnitude has really not been viable until recently, especially in a live hospital. But with the advancements of terrestrial laser scanning technology, software and hardware, and also process, it's really become more accessible. And this information, the feedback that we've got from the design consultants, this is just invaluable moving forward. But what was really special about this project, rather than just modeling the information from the point cloud, this model was also had added intelligence. So many people may be familiar with TrueView. We can essentially, we can now hyperlink this to your Revit model, Navisworks, CAD, or even PDF. And this enables you to jump right from your model to a virtual site inspection. And in TrueView, it's a bit like sort of Google Street View, it's a panoramic viewer, and essentially you can pan around in there, take measurements, do markups, and much more. We also geotagged assets with photos and ID, which we embedded into the BIM. So that's essentially, facility management data, like router IDs, switches, and essentially all the other services we've got in hospitals, which are absolutely momentous. So now we're going to look at aerial surveys and which aerial survey is right for you. Essentially, the first thing to consider is LIDAR versus photogrammetry. When I hear about people's bad experiences with aerial surveys, I would say that generally it's related to 99% of drone surveys use photogrammetry technology, which we touched on at the start, which is essentially stitching images together. But this can be problematic in vegetated environments and cause many to not trust photogrammetry or aerial surveys in general. But as you can see in the little image there, if you're interested in a DTM, which is the modeling the actual terrain surface, the ground surface, then you're really probably better suited to LIDAR in most cases. But 99% of drone surveys are photogrammetry, and that's essentially because LIDAR technology hasn't been as accessible until recently. And the next thing to consider is drone versus aircraft. Which platform is suitable, manned or droned? And I get asked a lot of the time, where is the crossover between, either getting large-scale airborne LIDAR versus a drone survey? The diagram that we've got there is just a bit of a guide on what you can capture from terrestrially from the ground in terms of resolution, as in either pixel size or point density, and then accuracy as well. So this is very much just a guide, and there's a big range on all of these, but also it's efficiency and capture as well. So if you're talking a very large site area, much more efficient to do it by a manned aircraft platform. If you're talking a smaller site and you're after higher accuracy or dense information, maybe a drone is more suitable. At Bennett, we're probably one of the, I guess, least biased. There's drone companies that might have some claims, and there's airborne mapping companies that have other claims. We do offer both services, so essentially we're not biased to pushing one way or the other. The case study we're going to look at today is the Macsween rock stabilisation. This project is part of the Miami headland on the Gold Coast, and it uses both LIDAR and photogrammetry, so it's a good example of that. And the survey is to facilitate a soft engineering solution to mitigate the risk of falling rocks to the public and provide an improved public space. So to do this job, first of all, to fly a drone over the site, it is very busy. There's a lot of guidelines around flying drones, which means we had to manage the crowds, make sure we don't fly a drone over people, and also there's a lot of air traffic around, helicopters and things like that. So we do have to satisfy the CAS requirements to fly that, which means you have to be a registered operator. So we captured survey-grade LIDAR, which to actually penetrate the vegetation. So what we're actually interested in is the rock surface on the cliff. So survey-grade LIDAR actually has multiple returns per pulse, so it actually penetrates straight through the vegetation, through all the little gaps in the vegetation, and maps the rock surface below. And so we then modeled this surface from the LIDAR to create a bare earth mesh surface, and then we draped aerial imagery on top of this mesh surface to create a textured mesh model. So the next thing we're going to talk about is as constructed conformance validation. So essentially there's a lot of different applications for terrestrial laser scanning or any other spatial data acquisition. But essentially, one thing to consider during construction sites is are things being installed to the correct specification? Whether it's installation tolerance, are they installed or are they not for progress claims, and also a record of maybe where services were laid. We can update BIM models and things to ensure that it's an accurate as constructed record. And also there's spatial data analysis. So whether it is monitoring movement, deformation of a structure, dynamic clash detection, spatial information can help, and it is important to consider at the start of a project. For example, we might have laser scanned a project just for the purpose of a detail survey, but down the stream on the project, hey, there's cracks appearing in a building, or maybe the road is subsiding. Well, if we've laser scanned at the start, we can laser scan it again, and we can then do a comparison and find out exactly how much it's moved and where. So another thing to consider is surveyors can offer more than just a PDF or 2D CAD. If you tell us what digital environment you're working in, chances are we can optimize a deliverable solution for your software. We do have countless software packages and experts that really do deliver and enjoy the challenge of delivering something custom for you. So happy to open up to the floor for questions. So I did receive a question. How do Bennett ensure and report on accuracy when extracting features from point cloud data? So look, if we're looking at maybe say a detail survey, if you're feature extracting surface for a detail survey, we do create a tin surface from the feature extractor strings. We then do a comparison against the terrain surface, against the point cloud. We can, through a heat map, we can then get a visual check of the actual DTM versus the actual captured point cloud. And that's actually the same when we're modeling in Revit for BIM projects. We'll essentially do the same thing where we do a heat map comparison showing the point cloud versus the model. Just got another one. How accurate is drone LIDAR? So it's always the interesting question. How accurate is the survey? So the drone LIDAR, like anything, it very much depends on the survey and how you're doing it. But as a general approach, the LIDAR will be accurate to about 50 millimeters at 2 sigma. So that's a 95% confidence interval. However, we often find that the actual surface extracted from the LIDAR is actually much better than that. And you actually get a very high definition surface created from the LIDAR. And essentially that that surface is, even though the point accuracy of a ground survey might be better, because you get much better definition from a aerial survey, often the surface is more accurate. We've got another question. What is the next step for surveying deliverables? That's a very good question. I would say, look, I think we're getting more and more people wanting to bridge the gap, I guess, from, everyone's working in a digital environment now and working, and I guess used to working in 3D. But I think that people get so stuck, whether it's in their BIM model, that they might not forget to reference the, how it references to the real world. So I think having that link between the real world and whether it is virtual site inspections into the model. So, for example, at the moment we're doing links from the Revit model to TrueView, or we can do the same thing with detail surveys, and we're really seeing the uptake in that. It's very, very popular. So you can jump straight from either 12D or even your PDF plan straight into the the online TrueView. Just looking at another question. How fast can you deliver a Revit model of a building based on area? Generally, we're not, I guess it's not based on area as such, it's more based on the detail that's being modeled. So for example, if we're modeling, 4 walls and a roof, well then, hey, that's it can be, turned around in a matter of hours. But if we're modeling complex MEP and structure, in ceiling services and all that stuff, well then I think we're generally talking weeks. If I'm to give a typical project, I would say it's generally a couple of weeks from site to turn around a Revit model. Just looking at another question we've got here. Once a large survey has been conducted, i.e. a large-scale drone LiDAR survey, how's the data presented? Does the client require specialized software to view, or will it work with manipulated model? So essentially, with any of these projects, whether we capture by aerial LiDAR or terrestrial LiDAR or photogrammetry, we can essentially deliver the information in any format that you're looking. So if you just want to work, if you're comfortable working in 2D, we can deliver in 2D. If you want to work in 12D, we can deliver in 12D. If you're more comfortable in Civil 3D or any other software package, we can present it in any format you require. Just got another query. In terms of digital asset management, facility management, is it more feasible just to just use digital scans and incorporate asset data web-based film platform instead of creating full 3D models like Revit, which is time-consuming and costly? Yeah, potentially. If people are comfortable working with point cloud data or referencing, you know, the reality capture information, then of course there's, you know, by all means we can certainly deliver the point cloud and you can do with it as you please. We just find that the vast majority of consultants working in the BIM environment are working in Revit, and they much prefer just pretty much give me a Revit file and I'll work with that. Point cloud data is very heavy, and also it requires interpretation, I suppose. So not all people are essentially have expertise and are comfortable working with it. About services in ceiling void, what is the accuracy that you can deliver? Look, the accuracy of the point cloud. So we generally terrestrial laser scan in terms of relative accuracy, you're looking at about 3 millimeters. However, a registered point cloud, depending on the projects, between 5 and 10 millimeter accuracy in terms of survey accuracy. And then we generally, typically, we would model within 20 millimeters of the point cloud. Look, we can model exactly to the point cloud if that's what you require. But generally, for modeling, you know, services in the ceiling void, we're not after millimeter tolerance, more is it there, how much clearance is there, and things like that. So it very much comes down to you know, having it fit the purpose. I think that's, unless anyone else has got any other questions that want to pop up, I think we're almost there. Okay. Well, yeah, I guess my details are there. Feel free to reach out direct if you, I guess, want any further information. I'm happy to do, you know, one-on-one sessions, you know, about specific items. I know we did essentially skim across a lot of items today, and probably didn't have time to go into a lot of detail. But yeah, happy to do a one-on-one with you, and if you get in touch, yeah, hope to talk soon. Thanks so much.